Okay. The reason the sun is longitudinal, show trouble in air, longitudinal, because the air molecules, okay, the atoms or molecules in air, okay, the air molecules are not bound to each other, okay, are not strongly connected to each other. Okay, that means air molecule cannot pull each other sideways like particle, like in string, right? They cannot pull neighboring molecules sideways. And also gases cannot support shear loads as well. However, air molecule can really bump one another. Okay? So they can bump one another back and forth. That's the reason. This is why sun is longitudinal. Okay? Okay? So I want to ask this question. This is just a question. This is just a question asked by my former students. Okay? So air molecules or air particles, they are not strongly bound to each other. However, they can move back and forth. Right? And move back and forth, this is longitudinal, right? Okay, so sun is, let's see the next slide. So sun is a pressure wave. Okay? Sun is the pressure wave. Longitudinal and pressure wave. Okay? So sun consists of the repeated compression C and reflection R. Okay? So as you can see, the sun travels C in this PowerPoint slide, right? It just travels C to R to C it just travels C to R to C to R. Okay? So, in brief, sun is longitudinal because air molecule transfer suns mainly by bumping into each other. Okay, back and forth. Okay? Because, student, as I said, they bump into one another. Right? They bump into one another. So this creates pressure, right? Because those air molecules bump with each other, bump into one another. So this creates pressures, high pressure or low pressures. Okay? So you can also say sun is the pressure wave. Sun is the pressure wave. Okay? So high pressure for compression and low pressure for rarefaction. Understand? So it just move back and forth. Those air molecules just move back and forth. That make the sun longitudinal wave. Understand? And also you can call it a pressure wave. Okay, C stands for compression. So this is high pressure. Okay, R stands for rarefaction. So this is low pressure. Okay, this is just a quick review for sun. Okay, actually, This is in physics. Okay? Alright? Okay, let me summarize. So sun's wave are first longitudinal. Okay? Because airs, they move parallel to a direction and they bump so move parallel. And they are also pressure wave because they bump one another. Okay, next I want to define, based on the frequency, I want to define sound. Okay, so the frequency range. So, frequency range. So the first one is called infrasonic, which means less than 20 hertz. What does hertz? Hertz means 1 time per second. So if I do something like this is 1 hertz. So if 1 second I collect 2 times, this is 2 hertz. Okay, so 20 hertz means 1 second collect 20 times or 20 circles. 20 cycles. Okay? All the above. All the above, based on human. So we human beings can hear the sound between 20 to 20,000. Okay? So we cannot hear the sound below 20. But dog can hear the sound below 20. Okay? And also we cannot hear the sound above 20,000. So above 20,000, greater than 20,000, we call this ultrasonic. Okay? So dolphin or whale, they can hear the sound above 20,000. They can hear sound, and they can have a sound in ultrasonic frequency range. They can produce a sound in ultrasonic. Okay? So the sounds produced by dolphin, okay, sometimes it's above 20,000 in ultrasonic. It's not, no. I don't know. I don't need. Okay, so you can produce a sound in ultrasonic. And also sometimes we call frequency pitch. Amplitude as volume. Okay, amplitude as volume, right? Okay? So next, we're going to talk about the bells and the decibels. Okay? So, actually they are the same. Okay? 1 decibel means 1 bell divided by 10. Okay? So, actually decibel means 1 over 10. Okay? Understand? 1 bell equals 10 decibel. Oh, 1 decibel equals 1 bell over 10. Okay? And this is the formula. Okay, this is the formulas. Okay, this is a formula. So the label equals the log Q over Q naught. And Q naught is the reference quantity. And the Q is what you measure. So you measure quantities over the reference quantity and take a log. So that's a label. And this is in pound. Okay, so 1 bell equals 10 decibel, right? So you can also type 10. So the L, so this is decibel, and this is bell. That's it. Actually, they are the same. Okay? They are the same. So electrons is bell. L is a decibel. Just simply divided by 10. Why? For convenience or for convenience. Okay, for convenience. Your bell is too large. Okay? And decibel is more reasonable in the real life. So just for convenience. Okay, just divide by 10. For example, you will use like centimeter for your height, right? You will not use kilometer. Okay, you will not use kilometer for your height. You will also not use nanometer for your height, right? Just for convenience. Everyone okay? Let's move on to the next. The next is the sun power and intensity. Sun power and intensity. So the W here. The W here, so W here, this is sun power. Divided by 10 to negative top. And LW, this guy is sun power label. Sun power label. In decibel. Sun power label in decibel. Okay? So the sum power equals energy. Okay, so it's in watt. Units in watt. And if energy over time, energy over area is called intensity. So the I is sun intensity. So sun intensity equals the sum power over area. Okay, that's the reason you can see the units. Okay, the unit is watt. Is watt times meter to the power to minus 2. Okay, so LOI is sun intensity as well. Intensity level. LO stands for level. Okay, so LOI is sun intensity level, and this is also in decibel. Okay? Everyone? Everyone? Okay. So this slide shows you another definitions. Okay. So the sum pressure level. Okay, sum pressure level. Okay, so because some meters usually measure the sum pressure, right? So we know the power intensity, but the problem is if we use some meter, if we use some meters to measure how loud the sound is, okay? Normally the some meters usually measures. The sum meter usually measures sum pressure. Not sum power. You got it? So, theoretically, okay, no problem for this slide. Some power, some intensity. But in practical, 实际上, in reality, in practical, 实际上, the sum meters usually measure some pressure, not some power. 可是，在测量声音的仪器，通常是测量声音的压力，而不是声音的音量。It's difficult to measure the power, right? But it's easier to measure the pressure. Okay, so in this slide, we are also going to introduce you some pressure level. So anyway, the arrow stands for level, right? And the P stands for pressure. Okay, so this is the definition for the sum pressure level. Okay, so it's 10 times log P RMS. So P stands for pressure. P stands for pressures. Okay, P stands for pressure, and RMS for mu mean square, which means effective value, and this is measured. So this one is measured. This is measured pressure. And the zero here stands for reference. Alright? And after that, if we check the squaring terms, right? We check this squaring, so the 10 becomes 20. Okay. So this becomes, they are the same measure. Okay, then just put the square to here. Okay. This is just mathematics. And the reference pressure normally we set as 20 micropascal. The reference pressure normally we set as 20 micropascal. So you can write this like 20 log measure PMS 20 micropascal. Okay. The micro means 10 to the power minus 6. Understand? Let's write this one down. Okay?
要帮我找一个，不是有一个海豚音的吗？啦啦啦啦啦啦啦啦，然后的很高的海豚，帮我找一下。你没听过吗？你们有没有听过？啦啦啦啦，然后有个海豚音。
Okay. Okay, I will show you next time. Someone can sing like a dolphin song. Dolphin song. Okay, let's take a look. So this is some pressures, and we can convert it to some pressure level, right? So the jet means airplane takeoff. So it's around 120 to 130. That's the fact, right? And average street traffic is around 80 to 90. And in business office around 60 to 70. In your living room, if no video, no TV and radio on, it's about 40. So the zero is the strike cell of gearing. So you cannot hear anything below 0. Okay? So 0 is threshold of one kind. It's a threshold of hearing. Okay, I found it. I will show you later. Okay. Okay. Everyone okay? So you can consider 60. This is normal. 60 decibel, probably normal. But above 80, this is gonna be very loud. Very loud voice. Although this thinks very well, loud voice equals noise. Okay, the loud voice. Even the guys sing beautifully. Okay, look, the singers sing beautifully. If the voice too loud, this becomes noise. Okay, so let's take a quick look. Okay, let me summarize this. So intensity. Okay, intensity is proportional to pressure squared. Okay, so intensity is proportional to pressure squared. And you divide it 10 times. You divide it 10, and bell becomes decibel. So because we take log for this, right? So student, because we take log for this, so 20 decibel. Okay, so 0 decibel means 1. If 0 decibel means 1, right? 10 decibel means 10. However, 20 decibel means 10 to the power 2, 10 squared, right? So 20 decibel means the output over input is 100. And 30 is 10 to the power 3, 10 cubic is 1 sound. Understand? Okay? So 10 times 10 times 10. Okay? And this is starting from 0. Okay? So plus 10 plus 10 plus 10. Understand? So that means every 10 times increase in power, keep plus 10 decibel. Okay, so this is 10 times 10. So this is times 10 times 10 times 10. But this is plus 10 plus 10 plus 10. Okay, so this is what I want to ask you. 90 plus 80 decibel. I'm going to ask the most handsome boy in this class. Okay, please do this question. 10 decibel plus 90 plus 80. I'm going to ask the most handsome boy in this class. Chen Junzi. Junzi Chen. Okay. His English name is Soto. You might also call him Soto Chen. 所以答案多少？170 OK 吗？He said 170. If answer is 170, I will ask my daughter. Okay, my daughter is in elementary school. Okay. If the answer is A, please raise your hand. B, C. You said D, okay? D. Okay. So how to do this? You can do this by two ways. Okay, first way, just do the calculation. Okay, please write this one down. Do I show you this? No, right? So the first way is do the calculation. Okay? This first way. And second way is we can use this. Student, okay? Everyone okay? Second way we can use this. Okay, for example, like this one, right? 55. 55 plus 51, right? So we can find out the delta L. Delta L is 55 minus 51. It's 4 dB. Right? So 4 is here. 4 is here, right? So goes up. Okay, it's around pretty close to 1.5, but we will say 1.4. Okay? So use the larger one. So answer will be 55 plus this difference, 1.4. You understand what I'm talking about? If you understand, please raise your hand. You just add up, right? So you have this 55 and you add up this, right? And the difference is 4 dB. The difference is 4 dB. Then this plus means add up, right? Then the T stands for total. So use this 4. This is this delta error, right? Goes up. We got this point. Pretty close to 1.5, but let's say 1.4. And use the higher one plus 1.4. So the answer is 46.4. Okay? So 55 plus 51 equals 46.4 dB. So this is dB. Not 106. Okay, I will ask TA. I will ask this question. Okay, I will tell you, I will ask this question in an exam. If someone answers 1 dB, not just minus the point, I will minus 10 for the, ask the TA to take off 10 points. I think Soto Chen will write 106. Okay? So it's 56.4. Okay? Okay, so let's hear this. Don't think so. I told you. Okay. Let's do it again.
we call this like dolphin sound, Haitun in Taiwan. But actually, as we know, the sound produced by dolphin, actually you cannot hear. Okay, because it's supersonic. Okay? Okay, so let's continue. So let's define noise. Let's define noise. So the noise, these words actually derive from nausea. Nausea means sickness. Okay? So even very beautiful voice like that, if I turn this very loud, and it becomes noise. Okay? So, but actually, okay, the noise is unavoidable. Okay? Or for many machines. So the reason we chemical engineering need to study this noise pollution or noise pollution control, because when we work in the chemical plants, we gotta deal with many machines. Okay, we try to lower or we try to prevent the noise or control the noise. Okay? And also, the noise negatively affect the human health. The human health. Okay? So noise meaning sickness. Okay? Sickness or discomfort. Okay, and there are lots of noise. Like now, the constructions also making noise, right? The traffic noise, aircraft noise, construction noise, factory noise, machine noise, loud noise. Your neighbor make some noise, right? Okay, so because we say noise is unavoidable, right? So we have some regulation for noise. Okay, we have some regulation for noise, but this is in the United States. Okay, so noise regulation made by in the United States, regulation made by the national government, or state government, or even the city government. Okay, so the purpose of noise regulation is because we just mentioned the noise actually will affect human health, right? So this noise regulation is used to protect public health. Okay, protect public health. And also try to reduce environmental noise and set noise limits and control noise source and guide local governments and reduce the conflicts. So for example, this one, the US Noise Control Act in 1972. Okay, so this one is important. Okay, this one is important because this is it recognizes. Okay, this law recognizes noise as environmental. Environmental pollutions. Okay, previously we think environmental pollution is like water pollution, like air pollution, right? But after this one, Okay, this one set. I mean in United States. Okay, in United States. In United States, this Noise Control Act define, okay, recognize and define the noise as environmental pollution. Everyone okay? Okay, so I think that's it for today. I think we can finish this and talk a little bit about the hazards next week. Okay? And remember the group you need to present, you need to give presentations. Okay, one group need to give a presentation on 28th. Okay, and remember the homework 3. Remember you need to submit the homework 3. Down here. Here. Remember you need to submit the homework 3 by May 20. And homework 4, I haven't posted, I will post it soon. On May 29th. And I will post homework 5, but you don't need to submit. 作业我不用交 You don't need to submit homework 5. I will post the post solutions on May 30. Okay? And the final exam will be held in IP 401. Okay, take attendance. 来点一下。